Of course, you can install it also faster, but you see how easy it is. Plug and play, set up. And now I will also share my screen and show you how to operate the web interface. Is my screen now shared? Okay, perfectly. So we can open the IP address of the web interface, which is 60.254. This is the default IP address. And let me hide all the screens here also. Okay, so we need to log in. The default password is password. And we can log in. Yeah, it's okay. We won't change the password right now. Now we can also open it in full screen, change to IOD configurator. And now we see on the left-hand side all the IO-Link devices on each port. And now we can, for example, start with the ODT3C. We tell that we are a specialist, so we have access to all the parameter. And over here you see numerical values of the set points, timer units, the same for the channel 2. We have teach commands over here. We get a teach result state. We have a lot of information. We can also do a factory reset and watch also diagnostic data like the status or observation. Over here you see the device temperature and also the counter of objects which are counted. So let's switch the process data. Over here you see a line graph, and now you can type or put in an object, for example this socket here, and you can move it around and you see you receive different values. You can, for example, put in customer objects and show them how it behaves with our sensor. So let's move on to the next sensor. It's a PRK. I mentioned before the special USP on this one is also you can output the measurement value. That means we are able to visualize how much power the sensor receives. And if we put in some transparent media, you're also able to see how it behaves on different kind of customer samples. Yeah. You can also test and show the tracking feature. For example, if you put a thin glass or a thin piece of glass in it, you can also show how tracking is working. So let's move on to the next one, KRT18B. I will only do a short hands-on with some short features. The detailed documentation you receive later on, because otherwise it's getting too long over here. So on parameter over here, you see also how it's taught, and over here you can load different kinds of receipts which are saved. If we change it right now, we saw that the color changed, or on this one. And you can also change the color directly over here. And then you see how the sensor behaves on different kind of marks with different kind of transmitting colors. You see it over here, process data. And if we move green to a red mark, you see the value, it's 8 to a white background. Now it's higher, or to a green background, to a green mark, it's lower. Yeah. So the next one is the ODT25B. It's a TOF device, also with a measuring output. You can also type in here the hysteresis and also the set points itself. And with extended diagnostics, you see you have a brightness which is in range, and you have a lot of information of values if the sensor is measuring fine or not. And on the process data, you receive also the measurement value. If you put in an object, for example, you see it's also pretty fast. You see the measurement value directly. The next one is the ODS9 laser class 1. The same over here. You have different type of parameters. That means you can adjust each channel independently. You can adjust the analog output, activate, for example, the background suppression, and of course you have commands for a quick teaching. Let's move on to the process data. Of course, you see also here a lot of diagnostic information, and move on to the process data. Over here, you see also, if I move an object, you see directly the value. The last on the top side is our HTU. The HTU is an ultrasonic sensor with the opportunity to change the cone of the ultrasonic cone, and there is here is the parameter sonic cone settings. You can adjust it to narrow, wide, and medium, and therefore you have a different behavior. And also, I mentioned before, we have a lot of diagnostic data. If we see diagnostics, you see the current temperature, the min, the max lifetime temperature, and therefore you can do a lot of analytics also with a power supply. And of course, you have histograms of a lot of values also. Let's move on to the process data. You have here an ultrasonic high precision sensor with 3 digits after comma. That means if you move objects, you can also see the chart. Let me clear it so you have the whole range of the operating range. Yeah, perfect. And of course, you see the other switching signals over here. Let's move on to the next device. It's on the bottom side. It's a tower light over here. We are able to change the segment mode, for example, to the level mode. Now we are on the segment mode, and we are also able to configure each color individually. On the process data, we can activate 3 different colors, for example. Write them down to the tower light. Now we see we have 3 different colors. And of course, we can also let them flash pretty easy by setting 2 bits. And now you see also we have a flashing light. As I mentioned before, there are a lot of parameters. We cannot watch them all today, but you get a detailed documentation how to configure each device itself. The last one is the MD742. It's an input hub, IO-Link input hub, and you are able to use 1 port on the IO-Link master and get up to 16 digital inputs on 1 IO-Link hub. That means if you have 8 hubs, you can multiply 16 by 8 and you receive up to 128 single digital binary inputs with only an IO-Link master and 8 hubs. So over here, let's go to the process data. You see the input 7B pin 2 is active, and we put something metal on it. It changes to input 4. So with one device, you can see that you can use 2 different inputs, but you can also use Y connectors like this one to connect up to 16 different devices on the input hub. So that's it for the presentation right now. Let's move back to the presentation on the screen.